8.4 compound interest. Now, when you take a look at this future value amount, A, you can see a totally different formula that we're using, and that's why I said pay attention between the word simple interest versus compound interest. So we have P parentheses 1 plus R divided by N, close parentheses raised to the NT. Once again, P is for your principal amount and your interest rate in decimal form still. N is the number of times you compound per year. How many times a year is the current interest amount going to be added to your current amount? And then you have T measured in years. Notice the exponent is N times T, the number of compoundings times the years. So let's get started on this. So in 8.4, we're working on compound interest. In this case here, we're looking at the wording. If we have semi-annual or even biannual, that is twice a year. N is equal to 2. So twice a year or every 6 months, interest will be added to the current loan amount. Next, we have quarterly compounding. Quarterly means 4 times a year or every 3 months that we will be compounding interest. Monthly, N is equal to 12. And if it says annually, that is just 1 time a year. Or if it says something like daily, it says daily compounding. Now it depends on the information given to you. What we normally would say is N is equal to 365. Now, some of the financial institutions will tell you that N is 360 because they're eliminating the 5 federal holidays. So that's up to the institute. They will specify, but when we say daily, normally in our reading, they will tell us 365 days. The principal represents an amount of money deposited in a savings account subject to compound interest at the given rate. So the principal P is $6,000. The interest rate is 3%. So remember, this is going to be 0.03 once we convert it to decimal. Compounded annually. So that says N is equal to 1 time a year, and time is 5 years. So part A is asking us to find how much money there will be in the account after the given number of years. So they're asking you to find the future value. And then part B says find the interest. So if you recall, the future value formula that was on the very first slide is A is equal to P parentheses 1 plus R over N, close parentheses, raised to the N times T for the future value. So we need to go in and insert the information that has been provided in the reading. We have future value is equal to $6,000. 1 plus my interest rate, which is 3/100, divided by 1, and raised to N is 1 times 5 years. And in this case here, once we go in and put it in our calculator, you need to be very careful. Remember, this gives you your future value. It tells us to round to the nearest hundredth. So we're coming out with 695 decimal 6444. Then around to the nearest hundredth. So $6,955.64. And this will be my future value. Part B is asking me to find the interest amount. We mark this as A, and then we're going to do B. So the interest amount. So you know the future amount, And now you also know the principal amount. So we take the future amount and you subtract the amount that was put into the savings, the $6,000, and you're going to end up with $955.64. And this is equal to the amount of interest that has accrued over 5 years. So once again, you take your future value minus the amount of money that was deposited, the $6,000, and you're left with the interest. So let me write this over to the side here. I is equal to future value minus the principal. There is another formula that you can use, knowing that we have A is equal to the principal times 1 plus R over N raised to the NT. If you know that N is 1, we could also use the following formula for the future value. We can use A is equal to P times 1 plus R, since we know the denominator is 1 for once a year, and raised to the T power. This is the formula you use if you are compounding interest once a year. So that is use if N is equal to 1. So there's all kinds of formulas that you can derive from one specific formula, but this is the one we can also use. All right, so find the accumulated value of an investment of $20,000 for 7 years at an interest rate of 4.5%. So what we need to do is go ahead and identify what we do know about this problem. So in this case here, we're investing $20,000. That's my P. 7 years is time T. Interest rate of 4.5%, that's going to change to decimal 0.45. This is R. And it tells you what is the accumulated value or the future value if the money is compounded semi-annually. And if you recall, semi-annually means N is equal to twice a year. So we're going to go ahead and use our formula. It does say round to the nearest cent. So our future value is equal to 20,000, parentheses 1 plus R, 45 thousandths, divided by N, which is 2, raised to the N times T, which is 7. And if we place this in our calculator, we should get 27309 decimal 668, which will round to $27,309.67. And this would be the monetary amount, the future value for this loan or investment, I should say. All right, let's take a look at the next one. What is accumulated value if the money is compounded quarterly? So this time they're saying N is equal to 4. Quarterly is 4 times a year. So once again, I'm going to take A is equal to the 20,000 times 1 plus the same interest rate, this time divided by 4, raised to the 4n times t. So 4 times 7. Again, be very careful when you place this in your calculator. Make sure your calculator looks like the exact insert of the formulas that you have right here. So this is coming out to 27357.03116 is what it looks like. Then round it to the nearest cent. That's what we're doing, rounding to the nearest cent. $27,357.03. And this is how much your future value of your investment is, compounding 4 times a year. Okay, and on the next one, let me see if I can go ahead and do this black color. We'll do round again to the nearest cent, compounded monthly. That's giving us N is equal to 12 times a year, so every month. And we have our future value equal to 20,000 times 1 plus same interest rate divided by 12. Close that parentheses, and now it's 12 raised to the 12 times 7. Now don't look at that as 12.7. Make sure you do a multiplication symbol in there. That's another mistake that happens when you go too quickly. So in the calculator, we're getting 27389 decimal 045.1, and this will round to the nearest cent. $27,389.05. So even though it's subtle, if you look at the fact that as you increase in the number of compoundings a year, we went from twice a year to 4 times a year to 12 times a year for compounding. You can see that the amount slowly increases. 27,309, 27,357, 27,389. So you can see that it's slowly increasing, but it is increasing. So the more compoundings you have per year, the higher the future value. Formulas for compound interest. So it says after T years, the balance A, the future value, in an account with a principal amount of P and an annual interest rate of R in decimal form, you have the following formulas. So the number of compoundings per year, this number 1 is the one that we've been using, and that is when you know N, the number of compoundings per year. The other option for compound interest is continuous compounding interest. And this one is A, future value, is equal to the principal times E raised to the RT. So rate times time is your exponent in this case. So you want to be careful. E is in your calculator. You should have to use either the shift button and the LN button. LN is for natural log. Or you may have on your calculator a second button, and then press your LN as for natural log. And this will give you that symbol E. All right, and if you take a look at E on the next page, you'll see how they're approximating it and what does E represent. All right, so for this table, what they're actually doing is using part of your future value formula, leaving off the P, leaving off the interest rate, and leaving off the time. So if you're just using this formula and you're inserting the number of compoundings, for instance, this is a 1 to begin with on the first row, and place it in that formula, they're coming out with 2. So as we increase in the number of compoundings per year, what's happening is that that formula is approximating to about the same value. So notice they're all about 2.718 towards the very end. And if you put this in your calculator and you can put e raised to the first power, I'm just going to do an approximation because I'm not writing all of this down. 2.7182, and then it just keeps going on. So you can see why we say E is an irrational number, because it's chaotic, it never stops, and it doesn't have a pattern. All right, so we're going to use E because the numbers on there go on forever, right? And this is the formula that we will be using for continuous compounding. Previously, we worked this problem finding the compoundings when n was 2, n was quarterly on 4, and then monthly at 12. And now this is the part D, and it says what is the accumulated value if it is compounded continuously. So whenever you see the word continuously, you need to go grab the correct formula, which is going to be A is equal to your principal times E raised to the RT. All right, once again, 20,000 is P, 7 years is T, interest rate in decimal form, 45 thousandths, and this is R. So we're going to substitute our value into our formula. We get A is equal to 20,000 times E raised to the R, 45 thousandths, times T, which was 7 years. Once again, you want to be very careful when you place this into your calculator. And we're going to round to the nearest cent. And this one, when you're done rounding, you should get $27,405.19. And this would be the future value, which this amount is much higher than all the other compoundings that we did, because this one compounds continuously. How much more would you earn in the first investment than in the second investment? All right, so here is our first investment, number 1. We have 52,000 for P for 50 years, time is T, and 10%. Let me change that to 0.1, or you can put 10 hundredths. Compounded annually, that's once a year, so N is equal to 1. Versus our second investment. So P is again 52,000, time is 50 years. R is 5%. Change that to decimal form. Compounded monthly. N is equal to 12. How much more would you earn in the first investment than the second investment? So they're already telling us that we should have a larger amount accrued for the first investment. And it does say round to the nearest dollar as needed. So you always want to wait and round at the very end. So let's go grab our first investment and see what we come out with. All right. So number 1, I'm going to look for my future value. I have $52,000 1 plus, remember if it's compounding once a year, I'm using the simplified formula, and this is 1 times 50, or just 50. And this is giving me, let's see, let me bring this back down here. A is equal to 6,104,324. And I have a decimal 35. And we're going to go ahead and round that. 6,104,324. Rounding to the nearest dollar. Okay, next we're going to go grab the second investment. And the future value here, 52,000. 1 plus 5% over 12. 12 compoundings a year. And it is 12 compoundings a year times 50 years. Again, be very careful when you place that in your calculator. It should look just like your problem that I wrote out. And we're coming out with 630,208. I messed that up. Let me back that up just a little bit. 7.927. So this is rounding to 630,208. All right, so we have the future value amounts, and now it's asking you how much more would you earn in the first investment than the second investment. So I'm going to take this first investment, and I will subtract the second investment. And that is giving me an amount of $5,474,116. Now say earned more on the first investment. So this would be your final answer here. And you can see that it is a huge difference. If you're compounding once a year, but at 10%, this is the future value. If you are compounding at 5%, even though you're compounding monthly, you're compounding at 5%, which is a much smaller interest rate, you only earn this amount. And I say only, that's still a lot of money. But then we have to go in and subtract to find the difference between the two, and you can have $5,474,116 more on the first investment. Dave won a photography contest and received a $1,425 cash prize. Will he earn more interest in 1 year if he invests his winnings in a simple interest account that pays 4%, or an account that pays 3.75% compounded monthly? So we have two different types of investments. We know that 1,425 is P. The first one is 1 year, simple interest that he pays for at 4%. And that's 1 year. So this is your time is 1. And R is 4%, 4 hundredths. on the first one, or in an account that pays interest of 0.0375 compounded monthly, which makes that n is equal to 12. So time is 1 for both, and the P, the principal, is the same for both. So I'll take a look at the first simple interest. The simple interest investment, what we do is I is equal to PERT. So I is equal to the principal, 1,425, times the rate, which is 4%, times time, which was 1. So the amount of interest that is earned off of the simple interest is $57. It says on here, will he earn more interest on the simple interest investment or the compound interest? So this is our simple interest investment on this first one. On the second one, I'm going to do the compound interest investment. And let's calculate this one. For this one, we'll have a future value, $1,425 times 1 plus the interest rate, 0.0375, 375 10,000ths, compounded monthly, which is 12, raised to n, which is 12, times time. And time, again, was just 1 year. And if you take a look on here, it does say round to the nearest dollar for these. So if I place this in my calculator, I'm coming out with 1,479.36, which when I round it is $1,479. All right, that is A. Remember, I don't want A. I want to know the interest amount. So remember, interest is equal to the principal amount, right? The future value minus the principal amount. So A minus P. So $1,479 minus the principal, $1,425. So my interest amount here is $54. Right? The simple interest investment had interest of $57. The compound interest investment had interest of $54. Will he earn more interest on the simple interest or the compound interest? So you can see that the answer would be the simple interest. And then if you look at these options on here, it said how much more interest will they earn? So we need to go in and take these amounts here and find the difference. So 57 minus 54 will give you $3 more interest on the simple interest account. So we are going to choose option A. He will earn $3 more in the simple interest account than on the compound interest account. So choose answer A. Calculating the effective annual yield. So it says, suppose that an investment has a nominal interest rate R in decimal form, and it pays compound interest n times per year. The investment's effective annual yield, Y, in decimal form is Y is equal to parentheses 1 plus R over N raised, all of that raised to the n power minus 1. And it says the decimal form of y given in the formula should then be converted to a percent. Then convert to a percent. Goodness. So that nominal yield is basically your interest rate before taking inflation in that case, or it could just be the stated interest rate. And if you take a look at your effective annual yield, what that does is it measures the annual return on an investment, taking into consideration how many compoundings per year. Sounds really elaborate. Just follow the formula. And you can see in the formula, you're going to need R, your interest rate, and N, the number of compoundings. A passbook savings account has a rate of 7%. So R is equal to decimal 0.07, 7/100. Find the effective annual yield. So they're telling you to find Y. Rounded to the nearest tenth of a percent. And it says if the interest is compounded semi-annually, so N is equal to 2. So if you recall, the formula for the effective annual yield is Y is equal to parentheses 1 plus R divided by the number of compoundings raised to the n power, subtract 1. Okay, so all we have to do is insert the values that we were provided. My interest rate is 7% over 2 times a year, raised to the 2 power, and subtract 1. So when you place this in your calculator and you just inserted the number 2 for the exponent, make sure you put a right arrow over to get out of that exponent mode so that you can do subtract 1. A lot of students rush this and they end up with 2 minus 1 as the exponent instead of we're subtracting 1 from the entire set of parentheses. So place this in the calculator, be very careful. And it says your effective annual yield is coming out to be, and this is really an approximation, 0.71225. We're rounding to the nearest tenth of a percent. So I need to change this to a percent, just like the instruction told me to. Move this 2 places to the right and add my percent symbol. So Y is equal to, and that is now a 7.1225%. Round it to the nearest tenth of a percent. Tenth is where this 1 is at. The number to the right is less than 5. So I am now going to round this to 7.1%. And this will be my effective annual yield, the amount that I need to enter into this box. So you can see though, even that the interest rate is 7%, you're actually earning 7.1% with those compoundings being twice a year. Determine the effective annual yield for each investment, then select the better investment. So we have the first investment is at 12.5% compounded monthly. So R is decimal 0.125. Compounded monthly means N is 12. There's my first investment. The second investment is 12.75. So R is decimal 0.1275. Compounded annually means N is equal to 1 time a year. So we're going to look at the first one and find the effective annual yield. It's asking us to round to 2 decimal places as needed. So I have Y equal to parentheses 1 plus my interest rate divided by the number of compoundings raised to the number of compoundings and subtract 1. Now, if you place this in the calculator, remember, double check your values. Make sure you have the decimal in the right place, that you're putting in the right numbers. And essentially, this is what I'm coming up with. Decimal point 132,416. And I'm going to round to 2 decimal places. But I need to change this to a percent first of all. So we'll move this 2 decimal places to the right. So that becomes a decimal after that, 3. So 13 decimal point 2416. And that's the percent. I forgot my percent symbol there. See what happens when we rush? And we want to go ahead and round to 2 decimal places. So the either stays a 4 or it increases. The number behind it tells me that it's going to stay a 4. So 13 decimal point 24%. All right, let's take a look at the second investment. This one we have y is equal to 1 plus, and the interest rate is 1,275 10,000s divided by the number of compoundings, which is just 1, and then we subtract 1. So this one here will turn out to be, in decimal form, 1275. Moving this into a percent form, we're getting 12 75/100%. So we found the effective annual yield for each one of the investments, and it's asking us to determine which one is the better investment. So let's take a look at what we have. So this one started out with a 12.5 investment on the first investment, 12.5% rate, and it is actually earning 13.24%. That's a big jump. The second investment, which was at 12.75%, is earning at 12.75%. So you can see the better investment in this case is going to be this first option, which is the 12.5% compounded monthly. So the title for this one says Planning for the Future with Compound Interest. So it says that if you have your future amount A, that's your accumulated value, and T is in years, R again is your interest rate, and compounded n times a year, the formula that we're going to use is this one that's listed. So it has the principal is equal to the accumulated value, all divided by parentheses 1 plus the interest rate in decimal form over the number of compoundings, close your parentheses, raised to the NT. So if you want to know how much to invest for the present value, you would use this formula.